Hello everyone. So my name is Roberto Infante. I'm a software developer. I tend to work mainly in the finance sector. I tend to implement risk management systems. So while working with one of my clients a couple of years ago, after following a bit Bitcoin from a technical point of view, experimenting a little bit with Bitcoin, around the beginning of 2016, I was in contact with a team that was starting to form a consortium with a few banks to develop a platform based on Ethereum, basically a platform to reconcile static data in an anonymous way across different banks, so that it could be tracked consistently with the blockchain technology, and however the technology in the end didn't prove to be the ideal one, but I got exposed to Ethereum and I got passionate about it, and I started to develop an interest. And while starting to research the technology for this project that in the end was done with a different technology, I started to learn by myself, as most people around 2016. There weren't too many resources. So in the end, I had the idea that given that there was no consistent resource to learn Ethereum in an easy way, I proposed a publisher the idea of a book. So in the end, I started this personal project. I started to write this book. The publisher obviously was interested because they saw that blockchain and especially Ethereum was an up and coming technology, and they thought it was a good idea. And the launch was around January 2018, which was at the peak of the blockchain craze, so it was kind of lucky launch around that period, but obviously it started to fade a little bit away, and it got just published a couple of months ago in paper. So however, the talk has nothing to do with the book, but actually it's kind of related with the book in the sense that while I was preparing the content of the book, there were so many things going on, obviously, in Ethereum. And actually, it was very challenging to write the book because every single piece of the Ethereum platform was moving. So it was quite hard to write something that could be used one year down the line, or even 2 years down the line. And at the same time, while I was preparing the content of the book, obviously, I had various ideas to put chapters on more experimental topics that were starting to be developed. But obviously with the publisher, we thought it was best to stick with the basic, I would say, core technologies for the book. So while preparing, writing the book, I focused mainly on the technology, but on the core technology like Geth, Truffle, all the core tools that you use to develop a distributed application, decentralized application from end to end. But on the side, I was still reading up on lots of topics and trying to sneak something in the book. In the end, I decided to put some of the most experimental ones in the last chapter of the book. But given I collected lots of material, I decided why not to present it, to give a talk on all the, I would say, technologies that are still fluid at the moment around Ethereum, and they are, I would say, they might be the next trends for the rest of the year or the months, the coming months. So the idea of this talk is again to talk about the evolving ecosystem, and with a special, I would say, focus on, I would say, the technologies that hopefully will give a better push on the adoption of Ethereum that is still not, although there is obviously lots of trading of ETH, but in terms of applications, there are interesting ideas being developed, but there is still not mass adoption given the technical limitations that are still impeding a bigger push to mainstream. So the talk is about all the technologies that hopefully will allow a better, I'd say, adoption of Ethereum in the coming months. So, so I will give a very quick overview of the current ecosystem, so everyone is on the same page, I guess. Lots of you are coming from different backgrounds, who is more technical, who has done some development, and who's just read about Ethereum. So I will try to keep quite kind of high level, but I will try to go a little bit more in depth on some of the most interesting concepts, although I will try not to go too deep. So the next stop, so I will start with just a presentation of the ecosystem, then I will highlight the main, I would say, limitation of the current Ethereum protocol and platform. I will try to present to you to give an overview of what is being, of how these limitations are being addressed at various levels in the ecosystem. And then I will just conclude presenting a few interesting trends that will be probably quite fashionable, let's say, in the next few months. And it will hopefully make the platform more interesting also for people from other blockchain platforms. So let's start with a quick presentation of the current ecosystem. So I'm going to just list quickly the main tools, just to give a background on the topics that I will present next. So I guess most of you know the concept of level 1. So level 1 means the core Ethereum technology. So it's the core protocol and the core tools like Geth, Parity, and some of the technology around it, like Swarm, like decentralized content systems, Whisper, all technology that's been developed by, I would say, the Ethereum core team. So some of this technology includes also languages, like if you have played a bit with Ethereum, obviously you'll have developed some smart contract in Solidity. You would have probably used some libraries like OpenZeppelin to develop the smart contracts easily. If you want to develop a full-blown DApp, including a UI, you have to implement some connectivity from the UI to the smart contract, and generally you'd use Web3.js. If you want to develop easily, you'd use kind of professional tools like Truffle that will allow you to work more in a, let's say, professional way, continuous integration and testing, and all of, I'd say, the practices that any software developer use in any language. Then security is a quite important concept of in the Ethereum ecosystem, because one of the, I'd say, I've talking about other developers, I've always noticed that although people are enthusiastic about the technology, they always a bit scared about the fact that the technology is new and there are potentially I'd say weaknesses that might jeopardize an application being launched into production, because not only of mistakes that you might make as a software developer on the application that you're developing, but also on potential weaknesses in the underlying platform because it's so new. So there are lots of security tools that are being developed at the moment that will allow easy checking of your code and spotting automatically weaknesses and all of that. Then there are other networks always part of the core ecosystem, like I mentioned, like content management and messaging, like IPFS, Swarm, Whisper protocol for messaging. Another important part of the ecosystem are oracles. Oracles are components that allow the blockchain, any blockchain, and also Ethereum, to connect to real-world data. Because as you know, blockchain processing is deterministic, so you cannot just connect to a streaming source that is gonna send you kind of real-time data that is going to change continuously. This data needs to be channeled in a certain way, so that every node of the network will process it exactly in the same way. And so oracles are an important component that allows just that. ENS is the Ethereum naming system. It's a little bit like DNS for the traditional internet. Makoto did a presentation on it a few months ago. Other major Dapps. Now, there is a trend at the moment about decentralized finance, DeFi, that is the area that hopefully looks like it's going to push bigger adoption of Ethereum, especially around security tokens at the moment. They are a regulated form of tokens. They are different from ICOs and utility tokens, in the sense that utility tokens are completely unregulated. Obviously, it's a good, I'll say, ground for people that with malicious intent and run scams. So whereas security tokens are completely regulated, and that's why recently, in the last few months, financial institutions especially are looking closely at that area, because they're going to be managed exactly in the same way, and actually with companies similar to the ones that run traditional finance. So it's an area that might push, that might inject capital into the blockchain ecosystem, and it might be an opportunity for growth. So, this was the, I would say, core, ecosystem that was, I'd say, applicable until a few months ago. Now, in the last few months, something started to evolve around all these components. So just quickly, I will mention what's changed, the main changes around the technology stack I've shown you before. So Geth and Parity are still the main clients, but there is, and Ethereum is being used mainly for prototyping, even by the core team. But there are, around the core clients, there are some new entrants in the managed clients area. Infura used to be the main managed clients. For managed clients, I mean, there are servers that you rent, and I've got the full installation of an Ethereum client, and you don't need to maintain your own local client. And that's useful also for development teams, because you don't want to continuously update your blockchain. And so you want to, if you want to develop more consistently, and you want to come back to a certain project after a few weeks, you don't want to waste time resynchronizing the blockchain and so forth. And so there are new entrants like Dapps Node, VIP Node, D-Node, and other companies that are starting to set up managed clients. Then there are new languages like Viper that is starting to get some adoption. Ether.js is starting to get adoption, the same adoption as Web3.js for the communication between UI and smart contracts. Then Truffle used to be the main development tool, but now ethldn or Embark as well has started to gain some adoption. Now, security tooling, as I said before, is an area that has got a proliferation of tools, and there are lots of interesting solutions there for checking automatically your smart contracts. So let's say if Oracle frameworks, as I said before, one of the main providers of technical providers of oracles is used to be called Oracle Eyes. Now they changed the name to Provable Things. I'm gonna skip. I was planning to give some explanation about how Oracle works, but I'm gonna keep it very high level because I think I'm concerned about time here. ENS. I've mentioned it. It was presented in another presentation. So decentralized finance, as I said, is an area that is gaining lots of attention. I would say the most important application, I would say frameworks in this area are the 0x protocol that allows to develop decentralized exchanges. So for a decentralized exchange, I mean at this level, I mean exchanges where you can swap ERC20 tokens and other like related token like ERC 721, like for non-fungible tokens, and but tokens within the Ethereum ecosystem. There are other technologies that allow you to swap tokens with other cryptocurrency across blockchains, but I will mention it later. But I would say the 0x protocol is one of the most important tools around within the Ethereum ecosystem, and the Hydro protocol as well is gaining some traction. In terms of major decentralized applications at the moment, the two main ones are Aragon and Augur that have, I would say, a considerable number of users, considerable within, I would say, Ethereum. So the core ecosystem, I would say, of strictly the tool that generally developer use would look like this, with the Ethereum clients and the development tools around it. But in general, the wider ecosystem, I would say, would look something like this. If you put also if you include the decentralized content networks like IPFS Swarm and decentralized messaging systems and all the other development tools that have popped up in the last few months. Now, so what's wrong with Ethereum 1.0? So although with the latest fork, the Constantinople fork, there was small improvements to performance and from a technical side to make the life of developers easier, there is still the big elephant in the room, which is the two main limitations that are affecting I would say the adoption of Ethereum are scalability. So the network is still not able to handle I would say hundreds of thousands of transactions that I would say traditional platforms are able to handle. And then there is a limitation on the privacy because obviously being using public Ethereum, just the strictly public Ethereum network, obviously privacy is a limitation, but there are solutions around it as I will show. So in terms of adoption of scalability, I just wanted to show just some charts that show the extent of the problem, that highlight the extent of the problem. So if you look at, so this is pretty much the capacity of the network. So one is full capacity. So you can see that since May 2017, we're reaching capacity, and obviously, and capacity is pretty high. Surprisingly, even if the number of transactions is not that high. I mean, it's around 1 million transactions per day, but 1 million transactions per day for any other system like credit card operators, for example, is a relatively small number. So the capacity, so there is, I would say, saturation of capacity with no much workload there. There are other, I would say, proofs of the fact that, there is a scalability problem. The number of recorded users, there are statistics about recorded users, apart from pure cryptocurrency transactions. Decentralized application users are no more than 50,000 per day, according to the statistics. So, and if you remember, the CryptoKitties craze showed that as soon as you put a little bit more load on the network, things don't work very well. So, but it's not all gloom. I'm going to show you the solutions that are started to be introduced into the ecosystem to address these problems. So there are two main areas of solutions, so-called L2 solutions. So level 2 is a layer on the top of the Ethereum blockchain. So it's not part of the core Ethereum ecosystem, so it's based on technologies that have been built on the top of it. So it's technology that still guarantees, provides the same guarantees as the core Ethereum blockchain, but it's not built in the Ethereum blockchain. So it's built on the top. And then L1 improvements are obviously being introduced with the Ethereum 2.0 with Serenity. So I will give you a very quick overview of what these innovations are. So L2 solutions, so level 2 solutions are mainly around two major areas. One is payment and state channels. So what's a state channel? It's a technology that freezes the state of some blockchain state in a smart contract, and then allows this state to evolve outside the blockchain in a system outside. So there is no limitation on what the system, on the technology of this outside system, provided that then this outside system is able to resubmit the final state. So I would say a netted state of all the evolution of the state that has happened outside the blockchain. So what's the advantage is that all these intermediate state changes that happen between a restricted set of participants are not recorded on the blockchain, but they're still recorded in this outside system. And so in the end, only the final state is resubmitted back to the blockchain. And obviously this improves the scalability because it limits, I would say reduces the number of transactions happening on the main blockchain. A similar solution is side chains, but side chains are based on a similar technology of Ethereum, so base blockchain technology, but it's smaller blockchains built on the side of the main chain. So the communication again is similar to that of state channels in that the main blockchain will hand over some state to this side chain, and then this state evolves in a separate blockchain that is smaller in size, so it's much quicker. It has a restricted set of participants. These can be even permissioned participants, so just participants that know each other and want to do business together. And then eventually, when I'd say collaboration between this participant and the state can be resubmitted back to the main blockchain. So again, same benefits of reducing the load on the main blockchain and allowing much quicker finalization of the transactions because they don't have to go obviously through mining. Plasma is an Ethereum implementation of this concept of sidechain, and it's a little bit, it provides a bit better guarantees than a similar technology, sidechain technology that was introduced for Bitcoin and other blockchains. So I'm not gonna go, if you are interested to know more about how state channels or sidechain work, you can have a look at the slides yourself. I'm not going to go into detail here, but I just want to emphasize a couple of points. So state channels can stay pretty much permanently open. So that means that once you've opened a state channel, once a set of participants have started to transact between themselves with using state channels, a state channel, they can let that channel open almost indefinitely, and generally one of the participants will partially close the state channel if you want to leave, or the state channel can even be closed if some participants notice malicious behavior. And anyway, there are some guarantees on the technology of the state channels that will prevent manipulation of state and submission of incorrect state back to the blockchain. So the two main benefits, again, just to reiterate, are higher performance because there is no mining, and privacy because all this state evolution that happens outside the main chain is private, completely private. Nobody has visibility of it apart from the participants possibly that are interacting together. One of the main technologies that has been developed in the Ethereum ecosystem on state channel is the Raiden network, and especially the micro Raiden sub network that allows micropayments. So at the moment, I would say most of the state channel concept is really a payment channel concept, because the easiest thing you can do is just to move tokens in and outside the network, well, outside the main blockchain, and then handle them there and resubmit. So there are other interesting side projects, but they're not related with these two main projects like Raiden. It's like Connex to Fanfare. There's a platform specialized in casinos. Counterfactual, which is a framework that allows you to build your own state channels. Side chains, it's a concept that appeared in 2014 in the Bitcoin space. Plasma, as I said, is the main technology in the Ethereum space. At the beginning, it started to get developed by Vitalik Buterin, but at the beginning there was a bigger ambition, I'd say, to progress with more impetus on this technology. But then it got focused on payments as well here in this. So there are, I'd say, most of the technology is being used for micro payments. The major Plasma implementations are Loom, the Loom network, Plasma Pay, or MySego. I would say Loom is the one more complete from a technical point of view, and they're pushing. I mean, the owners of this project are also pushing interesting concepts around integration with gaming, and also they've developed a kind of tool to teach Ethereum technology through this through the Loom network. This is pretty much the two main solutions, as I said. So state channels on one side and sidechain on level 2. Now level 1, the next, I would say, release of Ethereum 1.0 is going to just marginally improve on the current platform, but it's not a major improvement. The major improvement will come later. So this one is just the next release, which is in Istanbul, which will come across in October 2019. Is just around the proof of work algorithm. So they will try to make life a bit harder for ASIC-based mining, so that GPU miners will have a better return. But the major plan is mainly on Ethereum 2.0. So just touching the main points of Serenity. So there are, I would say, 3 or 4 major improvements that will come with the Serenity. So first of all is the introduction of proof of stake. So with proof of stake, I'm going to show you what I mean for proof of stake. So at the moment, you know that most blockchains are based on proof of work. Proof of work is based on competition between miners, so among miners. So every miner in the network is trying to compete against the others to try to append a block on the blockchain. So this causes, as you know, consumption of a very high amount of electricity, and also a kind of scalability problem, because you need proof of work is also time intensive. So going forward, there will be a set of validators rather than miners, and a validator will be picked by an algorithm so that only one validator will have to process a block. So it's a different concept. Now, a validator will put a kind of deposit, and if the validator proves malicious, that deposit will get confiscated. So obviously, the validators are encouraged to act to play well. The other improvement is sharding. Sorry, oops. So sharding is a concept that is already present in decentralized, in distributed databases. So if you have worked with databases, NoSQL databases like Couchbase or Mongo, they all use sharding, which means you distribute the records across of a kind of table or a collection across different servers. They are generally located closer to the users. A similar concept is being adopted also to improve Ethereum scalability. So nodes will store and process independently only a set of transactions, not all of them. I'm simplifying a lot, just to give you an idea of what sharding will do. Sorry. Then another improvement is the EVM, the Ethereum virtual machine, will be based on the new technology, which is more standardized, WebAssembly. So the new virtual machine will be called EWASM, based on WebAssembly technology. So these are the main, I would say, improvements on the core. I would say probably we could end the presentation here. I was planning to give you an idea of other related technology. I would say the main one outside, I would say, these improvements on scalability and privacy are atomic cross-chain swaps. So what's that? It's basically a technology that allows you to swap cryptocurrency across blockchains without having to go to a main centralized exchange. So most of you, if you have traded any cryptocurrency, you generally use the classic Coinbase or Kraken or centralized exchanges. But this new technology will allow you to trade with other peers without having to go to a decentralized exchange, and it will lock the cryptocurrency on both sides, and it will make a swap in one single operation with all the full guarantees that you will receive the cryptocurrency from the external blockchain, and your cryptocurrency will be transmitted to the other side. Security token, as well, as I said just at the introduction, is one of the main, I'd say, up-and-coming applications. There is a full ecosystem that is developing around it. there are lots of token flavors. They're appearing for all sorts of reasons. The next presentation probably will touch on ERC 721 on non-fungible tokens. They are being used for art trading, property trading. So these are oracles are being decentralized. So there is emerging technology. So I presented earlier oracleize or provable things. That is used to be the main oracle technology, but now there are some challenges to that, like Chainlink. Probably the crypto traders among you will have noticed that they spiked 70% up a couple of weeks ago. So Chainlink is one of the technologies that allows decentralized oracles. So I would stop here. I would leave space for the next presentation now.
Questions?
Yes.
Quick question. Should I take the microphone for questions?
Yes. Is it?
Or, no, that.
Ah, no.
Oh, no, sure.
Oops.
Any question? Yeah. The big job. Okay. The one question. We have one question.